This is section 4.3, and in this section we are going to learn how to manipulate radicals in a different way than using a decimal value of it. And we're going to learn some terminology, a mixed versus an entire radical. Now, you've got some reading that you can do here, but I'm just going to jump right into doing the questions, and I'm going to explain this paragraph in the process of doing it. Again, make sure you pause the video at appropriate times to stop and do a little bit of reading on your own so that you understand what I'm saying here and you want to connect that to what I'm saying out loud. So question number 1 says simplify the following radicals. Now, simplify a radical, you need to put one little thing in your brain that you're not going to forget. If I say simplify, you cannot have a decimal answer, and you cannot do anything in your calculator that produces decimals. Simplifying it merely means to take this number 8 and break it down into smaller numbers. Now, there's two methods that I give you on this sheet here. But for today's purpose, I'm actually just going to give you one method to be consistent to try and make it as easy as possible. You're going to go back to chapter 2 and you're going to break 8 down using that prime factorization that we did there, those factor trees. So over here, let's look at 8 and let's break it down into 2 and 4 and 4, which is 2 and 2. And so what I have then is that the square root of 8 is going to equal 2 times 2 times 2. The way square roots work is that any time you have a pair of numbers inside here, a 2 times a 2, that's really the square root of 4. Now what is the square root of 4? The square root of 4 is just a normal 2. No roots, nothing, just a 2. So anytime you see a pair of numbers inside here, you're able to pull those outside and they turn into a single one of those numbers outside. So 2 times 2 turns into a 1 2 on the outside. Now this guy here, he is trapped inside the root sign. And there we have it. The square root of 8 is written in a simpler form as 2 root 2. Now I'm going to do something strange, and I'm going to pull my calculator out, and I'm going to show you how to check this, or just kind of prove to you that they are in fact the same number. So let's find the square root of 8 using our calculator. So on my calculator, I go 8, shift, square root. I got 2.828. So let's just write that down. The square root of 8 is 2.828. Now, I'm going to punch in 2 root 2. And what that really means is there's actually a times sign between there. It means 2 times root 2. So on my calculator, I'm going to work a little bit backwards. And I'm first of all going to find the decimal value of this guy. And then I'm going to multiply him by 2. So the decimal value of root 2 is that. So that's what this guy equals. Now I'm going to times him by 2. What do I get? Do I get the same thing I had here? Absolutely. So the square root of 8 is identical to this guy. It's just that the numbers are simpler. 8 is big, 2 and 2 are small. So let's do the next one, the cube root of 54. Let's take 54 over here and let's break that down using our factor tree that we learned in chapter 2. This is going to be 2 times 27, which is 3 times 9, which is 3 times 3. Now, with the cube root for 54, it's going to be 2 times 3 times 3 times 3. Now, how does that work? Well, just take a look for a second. 3 times 3 times 3 is 27. What is the cube root of 27? Well, the cube root of 27 just turns into a normal 3 without any roots, just a 3. So what I'm trying to show you here is that if you have a cube root and you have a triple set of numbers, those triple set of numbers can be pulled out, and when they're pulled outside the root, there's just going to be one normal of them outside. 3 numbers inside the root for cube roots turn into a single one of those outside. They're gone now. Now who's left inside the cube root? That 2. Square root of 75. Square root of 75. 75 is 3 times 25, which is 5 times 5. So the square root of 75 is 3 times 5 times 5. This is a square root. Again, remember there's a little 2 there that you don't see. Square roots mean you're looking for doubles inside. A double inside a square root turns into a single outside the root. So we have 5 square root of 3. This is a 4th root. Now for a 4th root, we're going to be looking for not 2 inside, not 3 inside, but 4 inside. So let's take 243 and multiply that out. So 243 is equal to 3 times 81. 81 is 3 times 27, which is 3 times 9, which is 3 times 3. So what do we have here? The 4th root of 243 is 1, 2, 3, 4, 5 3s. 1, 2, 3, 4, 5. It's really important when you're doing these questions, if there's an index here, if there's a 3 or a 4 or 5, you cannot forget to write that down each time, because if you forget to write it, it means it's turned into a square root. You can't turn it into a square root. You need to keep that index there. So because we have a 4th root, that means we're looking for a group of 4 inside. A group of 4 inside comes out as a singleton for a 4th root. So this is going to be 3 4th root. Now who's left inside? These guys are gone. I have 1 3 left inside. Next page, just more of the same. Now, I say using the prime factorization method. That's just the method I taught you right now, and I'm going to stick with that method for all of these questions because I think it's the easiest. However, if you really want to, you can read the instructions on the previous page and see if you want to use that method instead. So 99 is 3 times 33, which is 3 times 11. So the square root of 99 is 3 times 3 times 11. This is a square root, which means we look for doubles. Doubles inside a square root turn into a single outside. This is 3. Inside we have an 11. Now the little note, don't make this 3 too small, or you'll think it's actually one of those little cube root signs. Make it a nice big 3 out in front. Now, 189. What goes into 189? Yes, just double checking that. 189 is equal to 3 times 63, which is 7 times 9, and then 9 is 3 times 3. So what do we have here? We have the cube root. I'm going to switch the order of this a bit. I have 3, 3, 3, and a 7. So I will put a 3, 3, 3, and a 7 for a cube root. Look for a triple. Let's pull this triple out as 1 for a cube root. 3 cube root of 7. 2940. Well, 2940, I don't think I'm going to have enough room here for this one, is going to be 2 times 1470, which is going to be 2 times 735, which is going to be 5 times 147, which is going to be 3 times 49, which is 7 times 7. What do we have here? We have a 2 times 2 times a 5 times a 3 times a 7 times a 7. This one's a little more interesting because we have a double here and a double here, and then a couple guys left inside. So what happens there? 2 times 2 comes out as 2, gone. 7 times 7 comes out as 7. Now we have a 2 outside. I'm not going to write 2 and 7 beside each other like 27. What I really have is 2 times 7. Now what's left inside is 15. This is 14 root 15. Now for this last one, we have a 4th root again, and we're going to show our prime factorization. Let's hope I have enough room here. So let us start with right here. I'll draw this line. We have 181.44. That's going to be 2 times 9,072, which is 2 times 4536. I think I'm going to run out of room, which is 2 times 2268, which is 2 times 1,134, and then divided by 2 again is 567, and then that's 3 times 189, which is 3 times 63, which is 7 times 9. Look at this, right to the end, which is 3 times 3. A lengthy process, but I think it's going to work fine. So what is this? What is 181.44 written as? 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5 2's. 1, 2, 3, 4 3's. And a 7. It's a 4th root, so we're looking for groups of 4. So 1, 2, 3, 4. These guys are gone. They come out as a 2. 1, 2, 3, 4. These guys are gone. They come out as a 3. What am I left inside? Inside I have the 4th root of 2 times 7. Now what do we have? 2 times 3 is 6, with a 4th root of 14. So again, this is called simplifying radicals. And the one thing that I didn't mention that I should have earlier, if you read the notes, you'll see that this right here is called an entire radical. And it's called an entire radical because all of the numbers that you see in the question are inside the radical sign. This is called a mixed radical because you have some numbers under the radical sign, some outside. A bit here, a bit there is a mixed radical. All of them under the root is called an entire radical. Here's your assignment for 4.3, and you can use the method I've shown you, or you can go back, read the notes from the first page in this particular section, and then you can try that method if you wish.